So this is going to be a multi-step question, just going through in terms of we have, it seems that we have excess and limiting, and then it's going to ask us, like running an experiment, if this is how much was produced, what will be the actual percent yield. So just start from the beginning, okay? So we have 45.15 grams of P4, okay? And they do give us a molar mass, which is 123.90 grams per mole. And when they give us the molar mass, we use that number in our calculations. We don't go back and then do it again in the periodic table, okay? And the other one they have is this mixed with 131.5 grams of Cl2, and the molar mass here is 70.91 grams per mole. All right, and now based on this equation they gave us, we have P4 solid plus 6Cl2 gas turns into 4PCl3 liquid. Luckily for us, this is already balanced out, so we're good to go, as they said. And now the first question they ask, how many grams of PCl3 can be produced from this reaction? So the molar mass of PCl3 is 137.33 grams per mole. So let's just tackle question A first, all right? Okay, because we need to figure out how many moles we're working with, all right? So with that being said, we have 45.15 grams, and the molar mass is 123.90 grams per mole. The formula to find moles for molar mass, okay, so the molar mass is moles per volume, per mass, okay, that's a molar mass. Sorry, whoops, it's the other way around. It's mass per mole, per 1 mole. So if you wanted to find the moles for it, okay, we would actually divide the mass given by that, because then the mass will cancel out and it'll just be left 1 mole. So look kind of like this: mass times 1 mole per the amount per mole. Okay, so that's what we're going to do here to find the moles of each one. So it's going to be now 45.15 divided by 123.90. So we have 0.364 moles. Okay, and the same thing for the other one, 131.5 divided by 70.91. We have 1.854 moles. Now with this information, to see how much is produced, okay, we first need to find out what the ratio is for the reactants. As you see here, because there's no coefficient here but there is here, it's 1 to 6. So that means the Cl2 has to be 6 times, at least 6 times greater for it to be considered the excess, that there's too much of it. So if we did the 1.85 divided by the 0.36, we should hopefully get a number of 6 or above. But funny enough, the ratio here, when you divide this by 0.364, that's equal to 1. That's equal to 5.0. So instead of it being a 1.6, it's 1 to 6 ratio, it's a 1 to 5 ratio. So let me just add the moles right under so you can keep track. 4 and 1.854 moles. So funny enough, even if it looks like we have so little of the tetraphosphorus, that's actually our excess, because of the fact that instead of it being 1 to 6, it's 1 to 5, meaning that all of that chlorine is actually going to be used up. So because chlorines are limiting, we're going to use that to figure out how many moles of PCl3 was actually made. So we have 5 moles of it, right? And the ratio here is 6 to 4. So we're going to do, to convert it to the 4, we're going to divide by 6, because that's going to be, in a sense, how many chlorines it takes, and then multiply by 4. And that will give us the actual moles of, sorry, I definitely did not need to do that. I need to actually use a 1.854, not the 5, because the 5 was just for the ratio. So it'll be 1.854, okay, divided by 6 times 4. And we get 1.236 moles produced, okay? And they were gracious enough to give us the molar mass. So here we just multiply together. So it's just be the moles times the molar mass to where the moles can cancel out. And we should get our grams. So 137.33. The amount of grams produced here is going to be 169.78, which is 169.8 grams. That's going to be how much of the product will be produced. So with that being said, we did establish that our tetraphosphorus was our excess. Okay, so how many grams of the reactant will remain? There's no more chlorine because that one was our limiting reactant. That one's gone. So now we have to figure out how much did it then use of the P4 since it was in excess. So we can go back to our 1.85 number. I'm going to do the same thing where we divide by 6 and we multiply it by P4's coefficient. But as you can see there, it's a 1. So we're really just dividing by 6 to see how much was used. So we actually, according to this, when we divide by 6, we used 0.3091 moles. So conveniently, it's less than the 0.364 as we predicted. So now we subtract to see how much is left, 4 moles, okay? So that is 0.055 left of the moles. And then now we convert it back to grams by what we did earlier, just multiplying. So multiply that times the 45.15, and we get our answer for B, which is 2.498 grams of P4 left. Okay? Now, the last question, if the actual yield was 101.2 grams, what is the percent yield? So the percent yield, okay, is calculated by what's it called? Experimental over theoretical. Actually, sorry. Experimental minus theoretical, the absolute value of it, times 100%. Okay, so the absolute value difference over the theoretical, which is what we calculated, and then times 100%. So in this case, it's going to be 101.2, all right, minus the number 169.78 divided by, remember it's the absolute, so it's no longer a negative, divided by that much. So we have quite a bit of a big percent yield because we multiplied that by 100. We have a whole, as we've calculated, 40.39% percent error. So the percent yield then would actually be how much we got based on that. So it will be 100 minus that answer, because I was already thinking of percent error, but percent yield is the other way around. So we have actually a 59.606 or 61% yield. So this would be more percent error. So percent yield is found by experimental. Well, it's going to be theoretical then minus experimental. So let's flip these around. Minus experimental. So that is what we're going to have for C. So just make sure this is going to be the yield. The one above was the error, because that's how much room there was in terms of what we had gotten wrong. So let's see how we did here. Based on this, yep, 0.3644. That is how much we got at 1.8545. That is also what we got for the Cl2. And then they should see that our limiting was indeed, just to make sure that we do this right. Yep, 169.79, which is what we got. How many grams of the reactants is left in the thing? So the excess will not have remained, so they subtracted it. Yep, and they got 0.055. But then here, as you can see, the P4 mass. Oh, whoops! I multiplied by the wrong one. I definitely should have done. I multiplied it by the 45.15, so that's why it was different there. So we have 0.55 multiplied by the molar mass is 123.90. So we actually have here, as the answer says on there, so it's good that we checked our work, 6.855. Yep, perfect. And the percent yield, it's actual yield over theoretical yield. Okay, so I was calculating the percent error. So with that being said, percent yield is just simply just the actual over theoretical times 100. So this right here, I'm going to fix this to say percent error, which is also used as well. So we're going to leave that there for now, but not put it as C. We're just going to leave that. So percent error, as I said earlier, was experimental minus theoretical over theoretical. But percent yield, which I'm going to put in blue here, is, as they said, just experimental over theoretical times 100%. So it's just face value right there. Experimental over theoretical times 100. So we have, just how they said, we got 101.2 divided by the answer, or divided by 1.69. Our percent yield is going to be 59.61% yield. So there you have it. And now our answers match. So just as how I did, just be careful that you are multiplying with the correct numbers, because that molar mass was a big error that would have definitely confused a lot of things. Luckily, we had a base to go off. And once again, the percent yield is just experimental over theoretical times 100. Okay, so that's correct. Let's move on to question number 16.